Laura Buchanan, and I'm an assistant professor in the chemistry department here at Vanderbilt. My group is primarily a physical chemistry group, but we're very interested in applications to proteins and protein structure. And so we do have wet lab space where my students do synthesis. We synthesize out of peptides, purify them, characterize them, and even have students doing a little bit of shrink line work to do unusual labeling schemes so that we can actually get site-specific resolution of protein structure with our spectroscopies. So, in terms of what systems we're interested in, we are very interested in proteins that aggregate, such as those that are involved in amyloid diseases like type 2 diabetes, Alzheimer's disease, and Parkinson's disease. We're also interested in understanding how proteins can be designed to form novel soft materials. Another project that we're working on looks at how proteins interact with nanoparticles. As nanoparticles are becoming more prevalent in our everyday lives, we want to understand how those nanoparticles interact with the proteins in our body when they're used for nanomedicine, or if we're accidentally exposed to them within the environment. So, to understand all of these problems, we use an ultrafast laser system. So, this is one of our two ultrafast laser bays. All of our work is based on a kilohertz titanium sapphire laser, which is a fancy way of saying a very high power laser that puts out very, very short pulses. And so those very short pulses allow us to look at how molecules move on those timescales of molecular motion. We do primarily infrared spectroscopy to look at vibrations, and so we have to convert normal 800 nanometer light from the laser into the mid-IR. And then we have this whole box, which is where most of the experimentation happens. And so we do a specific type of vibrational spectroscopy called two-dimensional infrared spectroscopy. It generates plots that look like these, and they allow us to see how vibrations within proteins talk to each other. And by seeing how they communicate, it allows us to better understand protein structure and how it changes as proteins aggregate and move and interact with nanoparticles. So if you're interested in learning more about how proteins change structure and how that can affect function, or if you're interested in working with ultrafast laser systems and designing new spectroscopic methods, or even if you're interested in our newest collaboration with Professor Joshua Caldwell to look at polaritons using our spectroscopies, please feel free to reach out.